Integrated Circuit 20, Digital Circuit, Advanced Subject, Ternary Logic. Okay, so what is ternary logic? The ternary logic is against the binary logic. So binary logic, 0, 1, ternary has 0, 1, 2. This can be one ternary. You can have -1, 0, 1. That is also ternary. And the first time ternary logic was proposed by the Russian scientist and tried to design the CPU using ternary logic, see how much it makes a difference. It's turned out that some area ternary logic has much more advantage than binary logic. And you think all the CPU is created by binary logic? Well, some of advanced CPU, the designer tried to use all kinds of methods to improve the performance, and some area ternary logic does better. So you never know what's inside the CPU. Don't think it's the designer used only binary logic for making the CPU. Actually, ternary logic is the area that is not exploited much yet. Okay, and I personally designed the CPU using ternary logic, and it was very successful. Okay, so what kind of ternary logic? The user binary logic, you can have a ternary logic. That is, 1 is 1, 0, 0 is 0, 0, -1 is 0, 1, and we have another 0. This artificial 0 is 1, 1. Okay, so actually ternary logic can be done by binary logic, right? And then we have some redundant bit. Hey, we are wasting. You may think so, but because of this redundancy, it gives a great advantage in the CPU design. And disadvantages, of course, well, you have 2 bits for every ternary 1 bit. So like a register size is gonna double, right? Unless you make a hardware gate which has a ternary logic. I'll show you the example. This kind of tri-level ternary logic, you define threshold V1 and V2, and the input signal has 3 different levels. Okay, the threshold is here, so you have 2 different threshold. Then input swing from here or here or here. This is +1, 0, -1. Okay, this takes more effort to do that. Okay, so in order to stay with the existing design concept, we use 2 binary bit for each 1 ternary bit, and that's the logical design will be much easier. Okay, so what happened is, what is good about ternary logic? Okay, suppose you have A and B. A can be -1 plus 1, or 0 or -1, 0 plus +1, 0, -1, and +1 plus +1, 0, -1. Okay, so the result is, this is a carry out, and result is 0, -1, 0, +1, 0, -1, 0, +1, 0. Okay, do you remember? This +1 is a problem. Why? When you have a 1 as a result, 1, 1, 1, many, and this guy you add, the carry propagate, and big portion of, well, not hardware wise, but the delay time of ALU come from this carry propagation. So in order to have 1, okay, we give a carry plus 1 artificially and make this guy negative 1. So if you have 1, 0 and negative 1 is same as 1. You get it? So we did this artificially, so carry change and x never get plus 1. That means you don't have a carry look ahead. So in a ternary logic, each bit AI and BI is added and it may generate carry out and carry in, but this carry never propagate. It's going to be added in the next AI plus 1, BI plus 1 and added there and settle. So LU speed become super fast. Adding number become so fast. You don't have to go through like 64-bit propagation. This bit may propagate all the way to 64. Even use a carry look ahead. Multiple stages carry look ahead. Let's go through and come back. This ALU is very slow because of the carry. The ternary logic, there's no carry for the propagation for carry. It's just added, that's it, one stage. So ALU speed, add and subtract to become super fast. So this is what actually I discovered and implemented in the CPU. I think there are a lot of more improvement can be done. Now disadvantage is it's increased hardware and also conversion between ternary to binary. Binary to ternary is easy, very simple. Ternary to binary, you have to do final addition, and that can be done on the way to memory. Within the CPU working area is register and ALU. We repeat this, and by the way, multiply speed up tremendously too, because there's no carry propagate. Carry is added and that's it, it's die out there. Okay, so within this CPU core part of the CPU, the number can be ternary, and when it goes to the memory, on the way to memory, convert into binary. Okay, because usually this path is longer going to the memory and it's not time critical and it can be pipelined. Okay, so when it can be pipelined, then conversion can be done when the data get out from CPU core, and this improves the speed of the CPU tremendously. That's a fast addition, subtraction, multiplication, and even division. Okay, so the ternary logic, this is the key here. When you design a logic, inversion is, this is inversion, and 0 is negative 0, is same 0, right? Plus 1 and 0 is 0, minus 1 and plus 1 is 0, so on. So you have to define ternary logic definition here. You have to work out the logic. Okay, and what you do is to get A and B for ternary logic, and this is a translation of binary logic. So using binary logic, the circuit element gates are made most of the time in binary logic, unless you make ternary logic gate like this. Okay, it's a challenge, but if you use a binary gate, then you need to have an extra term to handle this ternary logic. Okay, so this is multiply. Inverter is simple, and OR become extra term here. Okay, and this inverter is going to be exclusive NOR. Okay, so now this kind of logic using inverter, OR, and NOR of ternary logic entire CPU can be created. CPU is adder and multiplier. Okay, and this is really an area it's not explored much. There are a lot of academic papers still coming out, and it's kind of design secret. But I disclose you some effort made using ternary logic, using designing CPU chip. Okay, and this is a great way to improve, and probably it's secret in each company who make the CPU chip. Never know what they are using. Okay, so if you're interested in this field, you can still have a lot of room for improvement. It's not just LU, the multipliers, simple. The ternary logic is going to be quite different, and performance is going to be doubled. This stuff. Okay, so if you like this video, please subscribe.